Now that we've studied some of the preliminaries to our course, we're going to move on to some counting problems using two techniques called the additive principle and the multiplicative principle. So the first thing we're going to do is introduce some problems in counting. We're going to discuss the additive principle and how it relates to those problems in counting. We'll also discuss the multiplicative principle. And finally, we'll use both of those principles to solve some counting problems. So here's an example of a type of counting problem that we might run into. Ours are going to be a little bit more difficult, but this sort of gives you the idea of what kind of thinking that we're going to use. So for lunch, Jojo has a choice of 4 types of sandwiches and 3 types of salad. 2 different questions. The first is, if Jojo only wants one of these for lunch, either one sandwich or one salad, how many choices are there? If Jojo is super hungry and wants both a sandwich and a salad, how many choices are there in that case? So each of the above problems uses different operations in order to find the solution. For the first problem, each item on the menu represents a different lunch. So that way we use addition to figure out how many total. But the second problem figures out how many pairs of items, because each pair of item represents a different lunch. And in that case, we're going to use multiplication. So let's look at the first type of problem. Let's suppose Jojo wants only one of these for lunch, either a sandwich or a type of salad. How many choices are there? Now, this is a little bit different than the second problem. If one of the choices is, I know this is ridiculous, but a salad sandwich, and I put that in there because that might appear on both the sandwich menu and the salad menu. And if that is the case, how many choices are there? Now, the first problem, you just add the 2 numbers together. 4 plus 3 equals 7 choices. But the second problem is a little bit different. The sandwich menu and the salad menu have a common entry, which means that we're going to somehow get a different answer. And you can probably figure out what the answer is, but we're not going to look at this issue in this video. It's actually going to be in the next video on the principle of inclusion and exclusion. But the basic idea is, in order to do these sort of counting problems, it really matters whether or not the sets you have that you're combining have some elements in common. So what the additive principle says is, suppose you have 2 sets of object and want to choose one object out of the combined sets. So if you have m choices for the first set and n choices for the second set, and if the 2 sets have no objects in common, then combining the sets gives you m plus n objects. In other words, you can add up the number of items in each set as long as they don't have any items in common. So here's an example of that. Suppose you have a spreadsheet full of entries. The columns range from A to Q, and the rows range from 1 to 15. The question is, how many entries are either in row 8 or row 13? Well, we can think of this as being 2 sets of entries. The first set of entries is in row 8. The second set of entries is in row 13. So what we're going to do is, first of all, figure out if there are any entries in common. Since they're in completely different rows, there aren't any entries that can be in both row 8 and row 13. So that means the 2 sets have no elements in common. There are 17 letters between A and Q, which means that each of the above sets, each row, has 17 entries. That means if we want to find the total, we can just add them together. 17 plus 17 gives us 34. And we can do this even if we have more than 2 sets. We can have 3 sets of entries. So how many entries are either in column B, H, or P? Same setup otherwise. The rows range from 1 to 15. Well, in this case, we have 3 sets. 1 for each column. And every entry we count is in precisely one of the columns. That means there are no elements in common among those sets. There are 15 numbers between 1 and 15. That one's easy to count. So that means each of the sets has 15 entries. Since there are 3 sets, our total number of entries is 15 plus 15 plus 15, which gives us 45. So if we're going to look at the second problem from the very beginning, and that's the one where we're going to use the multiplication. And to remind you what that is, Jojo again has 4 choices for sandwiches, 3 choices for salad, and Jojo is going to get 1 sandwich and 1 salad. And then the question is, how many choices are there? So I'm gonna set up a grid to kind of show you how to organize these so that they're easier to count. So each row represents a salad. We have salad 1, salad 2, and salad 3. Each column represents a sandwich. We got sandwich 1 through sandwich 4. And then we pair each salad with each sandwich, and we get all those entries in between. And those are all the ways that we can pair a salad with a sandwich. Now notice that this is set up in a grid where we have 3 rows and 4 columns, and therefore if we want to add up the total number of ways that we can do that, we are going to multiply 3 times 4, which gives us 12 choices. So this is the basic idea that goes into what's called the multiplicative principle. So suppose you have 2 sets of objects. In this case we had sandwiches and salads. And suppose you want to count all the ways that you can pair an object in the first set with an object in the second set. If you have m choices from the first set and n choices from the second set, then there are m times n ways to put the objects into pairs. Right? We had 4 sandwiches, 3 salads, 4 times 3 ways to put them in pairs. So as another example, we again have this same old spreadsheet full of entries, columns between A and Q, rows between 1 to 15. And then the question is, how many entries are either in column B, H, or P? Same question as we had before. We're going to solve it in a slightly different way. So we're going to count each entry by pairing its row with its column. So in this case, our first set is the set of rows that we're counting. So we have row B, row H, row P. That's 3 rows. And the columns that we are matching those with, those are the columns 1 through 15. That is going to be the second set. So we have 3 choices for our number of columns. We have 15 choices for our rows. So as I mentioned, there are 3 ways to choose the column. Each column has 15 rows, which means there are 3 times 15, 45 entries. Again, the same answer that we got before, we just happen to get it in a slightly different way. So another way of thinking about the additive and multiplicative principle, and this is especially important when we're doing problems that seem much further removed from our pairing and our combining as they are now, is to think of them as counting processes. So we have all these objects, we're trying to count them, and we're trying to set up a process to count them so we can get an accurate count. For the additive principle, what we're doing is, okay, we want to count these processes. So suppose there are m ways of doing the process using one method, there are n ways of doing the process using another method, and if there are no ways of doing the process using both methods, then you just add up the number of ways of each method to get the total ways of doing the process. So choosing lunch, right? We had 4 ways to choose a sandwich. We had 3 ways to choose a salad. There is no way to choose both a sandwich and a salad at the same time since they're different objects. There are 4 plus 3 choices total. For the multiplicative principle, we think of the process a little bit differently. We think of cutting the process into pieces, into parts. So suppose we're trying to do a process and there are m ways of doing the first part of the process, and that for each way that you do the first part of the process, there are n ways of doing the second part of the process, then there are m times n ways of doing the entire process. So when we were choosing lunch, there were 4 ways, so we were choosing 2 items, so there's a 2-step process. The first step of the process is to choose a sandwich. There are 4 ways to do that. For each way that we can choose a sandwich, there are 3 ways to choose our salad, and that means there are 4 times 3 choices total for pairs of sandwiches and salads. So the additive principle, to sum up, we're adding complete processes together. We have all these processes, they are already complete, and all we're doing is adding them together, making sure that there are none in common between both processes. For the multiplicative principle, we are taking those processes in parts. We're multiplying different stages of doing the process. All right, so now I think you're ready to start thinking about some of the problems that we're going to work on. That is in the PDF file called Additive and Multiplicative Principles.